Now we're going to look at piecewise defined functions. A function is piecewise defined if it has different formulas on different intervals of its domain. So for the following piecewise function, now notice I've got f of x and I've got three different formulas, but which one I'll use will be dependent on my x value. So I have to first satisfy the if statement, and when I figure out where the x fits, then it tells me what formula I have to use. So for example, let's go find these. F of -2, my x value is -2. So I need to see, so I don't even look at these, I need to see where -2 fits. -2 is not greater than 5. -2 is not between or including 2 and 5. -2 is less than 2, so I need to use this first one. So using functional notation, I put -2 in, and I should end up with a -7. Okay. 1. F of 1. So my x value is 1. So again, go to your if statements, see where it would be true, and it would be true for this first one. So f of 1, if I put 1 in, I should have a 5. F of 2. Well, let's see. Notice I've got two 2's. So I have, is 2 less than 2? Or is 2 less than or equal to 2, which is less than or equal to 5? So this one fits in this second one. My answer should be 6. Now, if you'll notice, when I'm given an x value, it can only go to one of these. So only one of the if statements will be true. F of 6. Well, 6 is greater than 5, so I use this one. And I have to use order of operations. So 6 squared is 36, times 2 is 72. 3 minus 72 would give me a -69. Now these can be done by hand or by calculator. These weren't that bad, so I just thought I'd do them in my head. Got another one. Now on this one I'd like you to try A through D, so I need you to pause me and see if you know or end up with the answers that I have. Okay? So f of 5. F of 5 would fit right here, so I should have a -20. I don't know why it's jumping, so let me put my little thingy there. -1, where does -1 fit? It fits here, so if I substitute in -1, it looks like I should have -4. Stop that. This one, f of 2. 2 is not greater than 2, so I'm going to have to use the middle one. So 6 minus 1, that should be 5. Oh, this is getting irritating. We should stop that. Maybe it's that thingy, I don't know. -3, the middle one. So that looks like it should be a -10. Oh. Alright. Now, they want us to graph. Okay. To graph, I need to do one equation at a time. I have to do it in pieces, and then I have to worry about the x value. Now, this might take me a little bit of time because I've got to do it on here. So the first thing, I always start with the first one. So I'm going to get the slope, and get the y-intercept. And what's nice about these is that it's already solved for y. So let me move this down. Alright, so my first one, my slope is -2/1, y-intercept is 0, 0. I just happen to have a convenient point, so let me get it to the origin. I got to shift it a little bit. Now, I have got to go down 2, down 2, and over 1. It's not too bad. Now I'm going to try and use a straight line, but now I'm going to use a just a left arrow one. So let me get my, let's see if I can start here. And go through the origin. Nah, it's so-so. pull this so it'll be going through that one. Could do just a tad better. I guess I'll just leave it. But now I have got to have this where x is less than 3, so I'm going to shorten this to where x is at 3. And I'm going to move this dot. Do my best. But now it needs to be open. So let me open it up. So there's the first one. And notice it's just a piece. It has to be at x less than -3, which it is. Now if I put -3 in, I end up with a y value of 6, but it has to be an open dot because x is less than. So 1, 2, 3, 4, 5. Pretty close. Not bad. Okay, let's see the next one. Y equals 3x minus 1. Slope is 3. Y-intercept is 0, -1. So let me put my point here on 0, -1. And I've got to go up 3. So up 3, 1, 2, 3, and over 1. Okay, and now this one has got to be between -3 and 2. So let me go get me an equation, my stars, my straight edge. And let's see how I can do. Not very well. That's not too bad. But now I've got to get it at an x value of 2. So let me pull it back down to where it crosses at 2. Oh, -3, that's not too bad. But now these need to, because they're or equal to, they need to be solid. So let me get me some solid points here, because that means they include those. And if you put 2 in, see, here's this one right here. If you put 2 in, it is at 5. And if I put -3 in, to this one, it's at -10. Okay, so there's that one. One more. The last one. -4x. So my slope is -4/1. Y-intercept is 0, 0. So come on, point. Let me get it at the origin. So it's something that you've already done. You just haven't had to do it in pieces. So I've got to go down 4. 1, 2, 3, 4, and over 1. I'm getting a little bit better at this. Okay, let me go get me better. Now this works for x is greater than 2. So here's 2. It hits it right here. So let me move this down to 2. And let me go get this solid point. Now it is x is greater, so it's going to have to be open. So let me go open that thing up. Can I get rid of this point? Yay! Okay, there's my picture. Now, if you're doing it with graph paper and pencil, what's nice is you graph like you've done before, but then you erase up to that x value. So if it is less than or greater than, you use open. If it's or equal to, you use solid. So there's my picture. Not too bad. Let me get this other dot out of the way, make it prettier. I like it. So that's it for this section. Talk to you later. Bye-bye.